out IP packets with coded digitized speech in them. Another H.323 entity is the gatekeeper. And a gatekeeper is a set of functions that manage a zone. And a zone is a collection of terminals. And notionally we could think of it as a bunch of terminals all connected onto one LAN switch, and that would form a physical zone. But of course it doesn't necessarily have to be that way. A zone is just a group of terminals that are defined usually by somebody's brain, saying, okay, this gatekeeper is going to manage this group of terminals. And you don't have to have a gatekeeper, but if it's present, then there are certain functions that it has to perform. It has to perform terminal registration. So possibly the DHCP server is part of the gatekeeper. It's possible that the DHCP server is a separate box. But in any case, we have to find out what the IP address of that person's telephone is and store it somewhere in a little table so that we can do translations between people and IP addresses if we need to. And we also have to have information that relates what the LAN card address of the phone is to the IP address so that we can actually get stuff going to the right computer. Another thing that we would have to do is to authenticate a terminal, because we don't want to have a situation where people can start plugging their own terminals onto our telephone system, because you can imagine the possibilities for fraud. So we want to both register the terminal, find out what addresses it has, what person is using it, and then we want to also find out whether that's a real terminal or not. Now, another function that the gatekeeper performs is IP address resolution. And that can take a number of forms. One of them is if during call setup it gets a message saying, I want to exchange a phone call with Bob. Well, the gatekeeper would be the device that then resolves Bob into an actual 32-bit IP version 4 or 128-bit IP version 6 address. Another thing it might do is translations between public addresses and private addresses. It's possible that we use one IP address when we're going on a commercial or public network, but inside the building we're using a different regime for doing the addressing called private addresses. And so when a packet comes in to the gatekeeper, it's going to have to swap the public address for the private one to be able to send the packet to the right terminal on the in-building network. Another function that the gatekeeper performs is admission control. Admission control is deciding whether somebody's allowed to make a phone call or not. And there are two aspects of this. One is the obvious stuff, is that person allowed to make long distance phone calls? You can imagine conference rooms versus your desk. And then another question is, if we start running out of bandwidth at a capacity on the underlying circuits, do we start limiting the ability of people to start new phone calls for quality reasons? In the H.323 view of the world, we have one gatekeeper per zone, but of course we'd want to have two, because what happens if the gatekeeper dies? Nobody can do any more phone calls if that's what we're using to do phone call setup. So we want to have not only redundant gatekeepers, but we want to have automatic protection switching and load balancing between the dual gatekeepers that control a zone, a group of terminals. Now, in addition to these required functions, a manufacturer could start saying, our gatekeeper product has all of these other functions as well. And an obvious one would be accounting and billing. So coming up with call detail records. An AMA record is used in the business, and it's a record that identifies a phone call. And then we direct that to another system that then rates the phone call to figure out how much it's worth, and then usually yet another system then directs that to a particular bill. So we could either be performing these functions on a box called a gatekeeper, or we could be interfacing to systems that do these. Other functions would be quality of service and policing the wide area network links. As we've mentioned, the idea of call admission control is one of the easiest ways of policing a link. If the link gets busy, we don't let any more people onto it. But it can get much more sophisticated than that, of course. Now, there's no end to the list of functions that a particular vendor could include on their box. Advanced calling features like call forwarding or profiling, where you set up some profiles. If I'm in my office, then I want these phone calls to come through, those ones to go directly to voicemail, these ones to get rejected with a busy signal. If I'm on my cell phone, then I want the calls disposed of in this way. If I'm out of the office, then I want this to happen. So all of that could be set up via what a user sees as a web page and then actually implemented by software that's running on the same box that a particular vendor is called the gatekeeper. The list goes on and on. I mean, if you think about it long enough, you could have an interactive voice response system and automated call distributors and voicemail as part of the gatekeeper, and connecting to other applications like billing and accounting and authentication applications as well. The bottom line here is that a gatekeeper, if it's present, has to have the core functions of terminal registration, authentication, IP address resolution, admission control. And then a particular vendor could start adding on a whole bunch of other functions on their gatekeeper product if they wanted to. A gateway is another H.323 entity. I tried to delete the word gateway from my vocabulary because it was used to mean so many different things in this business. In the old days in IBM mainframes, a protocol converter was a gateway, and it converted between, say, DEC and Honeywell into the IBM way of doing things. In the early days of the internet, routers were called gateways, and we had the exterior gateway and border gateways and things like that. CGI scripts, that stands for Common Gateway Interface. I tried to just delete the word gateway because it means so many different things. But here it is back again. In the H.323 view of the world, a gateway is a protocol converter. And remember, there are two different areas to deal with. One is the media format conversion, and the other one is the signaling format conversion. When we say media, what we mean is voice, video, whiteboarding, whatever it is. And we have to convert from the way it's represented in the voice over IP world to some other format. An easy example would be voice that's been coded using one of the variable rate vocoders and high compression in voice over IP to be able to have to recode that into a DS0 stream to go onto the ISDN. Another example is, in theory, we could have video coded following the H.260 standards, and this is like a webcam, and in theory we could transcode that and turn it into NTSC, which is the standard for how to display stuff on your home TV in North America. As far as the signaling conversion goes, we have to convert between the H.225 registration admission status and Q.931 call setup signaling, which is used in the H.323 world, to the call setup signaling in the public switch telephone network. And we're going to take a look at this, of course, as we go deeper and deeper into the story. Those two functions, the media conversion and the signaling conversion, could be implemented in the same box, or they could be implemented in separate boxes. When we're talking about media conversion, we'd like to do that in hardware. That means that we're using a dedicated purpose processor that's been specially designed to perform this function, and it doesn't do anything else. That's what doing it in hardware really means. And when people are talking about media format conversion, they're often talking about codecs, coder decoders, or vocoders, voice coders, same thing, or transcoding from